Good morning, friends. Add it up. We're having some type of glitch. Well, good morning. Good morning. Good morning. I tried to do a different intro this morning, and it sounds like there was some form of glitch. I will have to go back and see what's going on with that intro. But good morning. Good morning for everybody who is here. Good morning, my friends. Good morning. So, little housekeeping before we get started. So, everybody who is new, who may not know exactly what's going on, I will explain. We are studying for the Comptia Dataplus exam. That is a vendor neutral exam, and this is the study group for that. So, it is a 6 a.m. to 7 a.m. Central Standard Time study group where we meet online virtually. It's about 3,500 of us in different parts of the world, all kind of getting on and streaming together. So we are going to go ahead and get started. This, as you can see, is the LinkedIn Learning portion. And so again, for those of you who are actually this is something that you want to do, you can use LinkedIn Learning. It is definitely a free for those that have the premium services. For veterans, you can get this as part of your services, as part of your premium services. If you need to know how to do that, reach out to me, DM me, find me on Twitter, wherever. I'll be happy to explain to you exactly how to do that. Okay, it's a pretty simple process. So let's get into it. Today we're finishing up on, we were pretty heavy into statistics
Trend analysis
last
seeks
time.
to
So
identify
let's get back
patterns
into
by
it.
comparing data over time. Suppose you work for a hospitality company with properties throughout the United States, and one of your goals is to evaluate corporate performance. To advance that goal, you can examine the total sales for each state over the past 5 years. As you conduct trend analysis, you can identify whether sales are declining, remaining consistent, or growing in each state. Understanding sales trends may then influence the company to sell unprofitable properties and invest in areas that show signs of sustained growth. In addition to trend analysis, you may also conduct performance analysis. Performance analysis examines defined goals and measures performance against those goals. It can inform the development of future projections. Continuing with the hospitality example, the company may have average occupancy goals for each property in its portfolio. Performance analysis can identify whether or not properties are achieving those goals. Combining performance analysis with trend analysis can help develop projections for the future. If you need to explore patterns and the connections between individual observations, you might want to perform a link analysis. Link analysis is a technique that uses network theory to explore the relationships between data points. For example, in 2015, there was a major data leak called the Panama Papers that released millions of financial documents. Journalists performed link analysis on that data to uncover patterns of unsavory financial activity, including tax evasion and money laundering.
Well, we got a quiz already. Wow, just getting into it and we got a quiz. You would like to measure how well an organization is achieving its goals. What type of analysis should you perform? Performance analysis? Which one of the following would not normally be considered a summary statistic? I don't know if it's variance, but it might be z-score. I don't remember this from the last one. It is.
Analytics professionals use a wide variety of tools in their work. From simple spreadsheets to complex business intelligence suites, we have many different tools available to help us meet both generalized and specialized analytic needs. When we're selecting a tool, there are a few important considerations that we should keep in mind. First, we need the right tool for the job. Just as a carpenter wouldn't use a screwdriver to drive a nail, an analytics professional wouldn't use a spreadsheet to create a machine learning model. Second, we need to choose from the tools that are actually available to us. Many analytics tools come with hefty price tags, and organizations only license a small subset of
All
tools to
right.
control their
That's
costs.
better.
Standardizing on a subset of tools also helps improve the ability of teams to work together. If every team in an organization uses different analytics tools, it makes it very difficult for them to collaborate with each other. Over the next few videos, I'm going to introduce you to a lot of analytics tools. I want to stress one point before we begin, however. You do not need to know how to use all of these tools when you take the Data Plus exam. The exam objective here is that you be able to identify common analytics tools. Comptia specifically says that you do not need to know specific vendor feature sets. The spreadsheet is the most widely used tool in the world of analytics.
Of
It's
course,
hard
that's
to imagine
Excel.
anyone who doesn't use spreadsheets as part of their work because spreadsheets provide an intuitive way to organize our data into rows and columns. Spreadsheet software is installed on pretty much every computer in the modern work environment, and web-based spreadsheets are freely available to anyone. Spreadsheets are productivity software packages that allow users to create documents that organize any type of data into rows and columns. Users can place any data they like in the spreadsheet and then quickly and easily perform mathematical calculations, such as finding the sum of values in a row or searching out the minimum, maximum, mean, and median values in a dataset. Spreadsheets lack any of the constraints of a relational database. While you can certainly organize data in a spreadsheet, there's no requirement that you do so. If you'd like, you can mix numbers, text, dates, and other data elements all in the same column. Now, that does, of course, reduce the usefulness of the spreadsheet, but the user of spreadsheet software has total flexibility in how they organize their data. The power of spreadsheets comes from the fact that virtually anybody can use one. The barrier to entry is low because spreadsheets are readily accessible and easy to use. If you need to perform a quick ad hoc data analysis on a fairly small set of data, spreadsheets offer an easy way to do that and then share your work with others. More formal business needs often stress the capabilities of a spreadsheet. Once many people need to access data and you have a
Now
desire to
you have
keep
to
a
go to a
centralized and
database,
managed
which
data
requires you
store,
to know
these
SQL.
requirements often drive a move of that application from a spreadsheet to a relational database. Microsoft Excel is the most commonly used desktop spreadsheet application. It's available as a component of the widely deployed Microsoft Office productivity suite, and most modern knowledge workers have access to Excel. As with any spreadsheet, you can store data of any kind in an Excel spreadsheet. Here you can see an example of an Excel spreadsheet containing data on restaurant inspections conducted by the City of Chicago. This particular spreadsheet is organized in the same way you might organize a database table. Each column represents a particular data element recorded about each inspection, and each row represents a single inspection event. Excel allows users to perform calculations and visualizations on their data. You might want to count the total number of restaurant inspections, determine the average length of time that an inspection takes, or compute the number of inspections conducted each day. You can perform almost any simple analysis you might need right in the Excel spreadsheet. Here you can see an example of a quick visualization showing the results of inspections conducted by the city. The power of Excel comes in its simplicity and availability. Pretty much everyone in a business has Excel installed on their computer and likely has at least a basic understanding of how to use it.
Of
In many
course.
cases, business analysts and data scientists need a way to be able to load, manipulate, and analyze data outside of the constraints of software written by another organization. In those cases, they might develop their own software to meet a specific need. In fact, many skilled analysts find it easier to write their own code to perform many analytics tasks than to work within another analytics package. Programming languages allow skilled software developers to write their own instructions to the computer, allowing them to directly specify the actions that should take place during the analytics process. Now, you do not need to know how to program on the Data Plus exam, and you shouldn't expect any questions that ask you to write or interpret code. You should instead focus on the purpose of programming languages and where they can fit into an analytics environment. The R programming language is very popular among data analysts because it's focused on creating analytics applications. R originally appeared in the 1990s as a statistical programming language that was popular among a niche audience. More than 3 decades later, the language has evolved into one of the most popular languages used by statisticians, data scientists, and business analysts around the world. R rapidly gained traction as a popular language for several reasons. First, it's available to everyone as a free, open-source language developed by a community of committed developers. This approach broke the mold of past approaches to analytic tools that relied upon proprietary commercial software that was often out of the financial reach of many individuals and organizations. R continues to grow in popularity because of its adoption by the creators of machine learning and other analytics methods. Almost any new technique created today quickly becomes available to R users in a redistributable package offered as open source code on the Comprehensive R Archive Network, CRAN, a worldwide repository of popular R code. One of the most important advances in the R language was the creation of a set of R packages known as the Tidyverse by Hadley Wickham and other developers. The Tidyverse approach to data analysis simplifies the use of the language and makes it accessible to anyone willing to invest a few hours in learning some basic syntax. Most modern R developers choose to write, test, and deploy their code using an integrated development environment, or IDE, called RStudio. The RStudio graphical interface shown here provides a well-designed environment to manage your code, monitor its execution, and troubleshoot issues that might arise in your R scripts. The Python programming language is arguably the most popular programming language in use today. Python is about the same age as R, but the major difference between Python and R is that Python is a general-purpose programming language. This means that it's capable of creating software to meet just about any need that you might imagine. You can do everything from code a video game to perform a complex data analysis in Python. With that flexibility, however, comes some complexity. While R is very popular because of its ease of use, writing software in Python requires some more expertise. Python developers usually have a more formal background in computer science, and they're familiar with many coding concepts such as looping and branching that aren't necessary in most R code. Python also has specialized libraries that focus on the needs of analysts and data scientists. In particular, the Python Data Analysis Library, Pandas, provides a set of tools for structuring and analyzing data. Here you can see an example of Python code performing data analysis with Pandas. The structured query language, SQL or SQL, is the language of databases. Anytime a developer, administrator, or end user interacts with a database, that interaction happens through the use of a SQL command. SQL is divided into 2 major sub-languages. The data definition language is used mainly by developers and administrators. It's used to define the structure of the database itself. DDL doesn't work with the data inside a database, but sets the ground rules for the database to function. The data manipulation language, DML, is a subset of SQL commands that are used to work with the data inside the database. DML commands don't change the database structure. They add, remove, retrieve, and change the data inside the database. As you prepare for the exam, you should be familiar with the major commands used in SQL, but it's important to understand that you're not responsible for writing or reading SQL commands. You just need to know what the major commands are and when you would use them. There are 3 DDL commands that you should know. The create command is used to create a new table within your database or a new database on your server. The alter command is used to change the structure of a table that you've already created. If you want to modify a database or table, the alter command lets you make those modifications. The drop command deletes an entire table or database from your server. It's definitely a command that you're going to want to use with caution. There are also 4 DML commands that you should know. The select command is used to retrieve information from a database. It's the most commonly used command in SQL, as it's used to pose queries to the database.
It's your first line of your code. Select From
The
where?
insert command is used to add new records to a database table. If you're adding a new employee, customer order, or marketing activity, the insert command allows you to add one or more rows to your database. The update command is used to modify rows in the database. If you need to change something that's already stored in your database, the update command lets you do that. The delete command is used to delete rows from a database table. Now, don't confuse delete with the drop command. The drop command deletes an entire database table, while the delete command just deletes certain rows from the table. Users, administrators, and developers access databases in different ways. First, a developer, administrator, or power user who knows SQL might directly access the database server and send it a SQL command for execution. This often happens through a graphic user interface, such as the Azure Data Studio interface shown here. This tool allows you to write database queries in SQL, send them to the Microsoft SQL Server database, and then view the results.
Right now, I'm
Utilities like
using
Azure Data
BigQuery
Studio can do more
through
than just retrieve data. They
Google
also
because
offer
I'm
a
taking their
graphical way
course
for
as
database
well.
administrators to
So
reconfigure the database.
the
You
BigQuery
click through
one
a
works
series of
really
menus
well.
to choose the changes that you'd like to make to the database, and the utility will write the SQL commands that carry out your requests and send them to the database. Similarly, there are many query and report builder tools available that
Oh,
simplify
Tableau is
database
on its
access for
way.
end users, allowing them to click
Well,
through a
that's more
series of menus and
visualization.
drag objects
Yeah,
around on the
true.
screen
That's more
to retrieve
visualization
data
and
from a
not so
database.
much as
These tools then translate those
just
actions into select statements that retrieve the
report
desired
builders because it's not
information from the
necessarily a report
database.
builder. Tableau is
Finally,
more
computer software can
visualization of your
interact with
data.
databases programmatically. This just means that software can send SQL commands to the database as part of its activity. For example, when you fill out a form on a company's website, chances are that software is processing that form and then storing a record of your activity in a database. Now, of course, not everyone has the ability or desire to write their own software. It's often far simpler to work with software packages that provide the capabilities that we need. Statistics packages are a great example of this. These software packages go beyond the simple statistical analyses that are possible in spreadsheets and provide access to advanced statistical environments that are accessible through a graphical user interface and/or a built-in scripting language. These software packages may be used by anyone interested in data analysis, but the reality is that they're mainly the domain of professional statisticians. Generally, data analysts with a computer science background tend to prefer using programming languages to write their own code, while those who do not have a strong background in statistics or coding generally prefer some of the more visually oriented tools. One of the most popular pieces of statistical software is IBM's
Oh,
SPSS
SPSS. They
package.
had that on last night's
SPSS is
class
one of
for
the oldest
360,
statistical software packages. It
360
was
data
first released in
science. We were talking about
1968, but it
SPSS.
continues to be used today by many statisticians.
Yeah,
Here you can see an
that was pretty
example
cool.
of calculating the correlations among a set of variables using SPSS. SAS is a statistical package that's quite similar in function and form to SPSS. Like SPSS, SAS is also a long-standing pillar of the statistical software community. It was first released in 1976
And you
also
can tell,
continues
look
to
at
be
the
widely
graphical
used
interface
today.
for it.
Here you can see an example of a simple data analysis being performed in SAS. Stata is yet another statistical analysis package that dates back to the 1980s and continues to be updated today. It offers essentially the same features as SPSS and SAS, and it provides users with both a graphical interface and a command line interface depending upon personal preference. Stata is less widely used than the more popular SAS and SPSS tools. Here you can see an example of building and visualizing a linear regression model in Stata. Now, the final statistical software package covered on the Dataplus exam is
Mint?
Minitab. And once again,
I thought it
Minitab
was
shares most of the same features as
MATLAB we were talking
SPSS,
about
SAS,
last
and
night.
Stata, but it fits into the same category as Stata. Minitab is an older tool that's not widely used today. Here you can see the evaluation of a linear regression model in Minitab. Moving on from statistics-focused tools, data analysts also make use of a set of graphical tools that help us build machine learning models without requiring that we actually write the code to do so. These tools aim to make machine learning techniques more accessible. Analysts can still tune the parameters of their models, but they don't necessarily need to write scripts to do so. IBM's SPSS Modeler is a popular tool for building graphical machine learning models. Instead of requiring that users write code, SPSS Modeler provides an intuitive interface where analysts can select the tasks that they'd like the software to carry out and then connect those tasks in a flowchart style interface. Here you can see an example of this
Hmm.
interface being used to create a decision tree model of consumer credit data. Once the user is satisfied that they've designed the machine learning process they want, they then run the model and are able to visually explore the results. Here you can see the result of executing the decision tree model on consumer credit data. RapidMiner is another graphical machine learning tool that works in a manner similar to IBM
A
SPSS
rapid
Modeler.
miner. Okay.
RapidMiner offers access to hundreds of different algorithms that can be
I've
placed in
never
a
heard of that one,
visually
so
designed machine learning workflow. RapidMiner also offers pre-built analytic templates for common business scenarios. Here you can see the visual design of a decision tree task in RapidMiner, and here's the result of creating that decision tree in RapidMiner. The presentation of results is not quite as visually appealing as the decision tree in SPSS Modeler, but it provides similar information to the analyst. Today, most organizations choose to adopt an analytics suite that provides powerful capabilities crossing all phases of the analytics process. These tools allow analysts to ingest and clean data, perform exploratory data analysis, visualize their data, produce models, make predictions, and communicate and report their results. These suites are normally more expensive than the other tools we've discussed, but they also provide an end-to-end environment where all of an organization's analysts and developers can work together on analytics projects. IBM Cognos is an example of one of these integrated analytics suites. Cognos uses a web-based platform to offer analysts within an organization access to their data, and it's backed by IBM's Watson artificial intelligence capabilities. Power BI is Microsoft's analytics suite built
yep.
upon the company's popular SQL Server database platform. Power BI is popular among organizations that make widespread use of other Microsoft software because of Power BI's easy integration with those packages and cost-effective bundling within an organization's Microsoft Enterprise License Agreement. MicroStrategy is an analytics suite that's less well known than similar tools from IBM and Microsoft, but it does have an established user base. MicroStrategy offers many of the same tools as its counterparts, making it easy for users to build dashboards and reports and apply machine learning techniques to their business data. Domo is a software as a service or SaaS analytics platform that allows businesses to ingest their data and apply a variety of analytic and modeling capabilities. Domo isn't a very widely used tool, but knowledge of it is included in the objectives for the Data Plus exam.
Hmm.
Salesforce
Interesting.
Datorama is an analytics tool that focuses on a specific component of
Yes,
an
but it is
organization's
so
business,
huge,
sales
Data
and
Roma
marketing.
is.
It's not a general purpose analytics tool, but it's instead focused on applying machine learning, visualization, and other analytics techniques to the sales and marketing process. AWS QuickSight is a dashboarding tool available as part of the Amazon Web Services cloud offering. This tool's power comes from the fact that it's available on a pay-as-you-go basis, and it has integration with the powerful data storage, data warehousing, machine learning, and artificial intelligence capabilities offered in the Amazon cloud. Tableau is arguably the most popular data visualization tool available today. The
Agreed.
focus of Tableau is on the easy ingestion of data from a wide variety of sources and powerful visualization capabilities that allow analysts and business leaders to quickly identify trends in their data and drill down into specific details. Qlik is another popular SaaS analytics
Oh, I
platform,
thought that began with
offering
a
access
C.
to cloud-based analytics capabilities. Here you can see a financial analysis performed in Qlik of an organization's operational processes from orders being placed through fulfillment, billing, and receivables. Business Objects is an enterprise reporting tool from SAP that's designed to provide a comprehensive reporting and analytics environment for organizations. One of the strengths of the Business Objects suite is the ability to integrate Business Objects reports with other applications, allowing organizations to integrate analytics into other portions of their workflow.
All right, so we finally have our test or quiz, not a test. So, what analytics suite is offered by Microsoft and directly integrates with SQL Server? That's Power BI. You should always choose the analytics tool that is most appropriate for any given situation, even if it means acquiring a new tool. Oh, so it was. Wait, did I choose? I chose true. Interesting. When I knew it was false because it said always, but you are working with a professional statistician to perform an analysis and would like to use a statistics package. Which one of the following would be most appropriate? Rapid Miner? I don't know. Okay, then maybe it's Mint Tab. Okay, because I know what Power BI is, but I had never heard of Rapid Miner. Um, what SQL command is used to delete an entire table drop? Which one of the following programming languages is specifically designed for use in analytics applications? R?
Thanks
Move it
for
along.
watching my Comptia Dataplus data analysis course. It's been a pleasure joining you for this journey through the world of data analysis. I hope that as you've completed this course, you found it interesting and helpful in preparing for the Dataplus exam. You should now have a solid foundation for the data analysis domain of that test. If you're following the Dataplus course series in order, you should now turn to the Dataplus visualization course. Otherwise, you can move on to any of the other 5 courses in the series. Good luck with the rest of your test preparation.
All right. So we, of course, are going to download our certificate. We will definitely have that. We are going to download the PDF version of that so that we have it. We will also put this in the public eye. And why this portion is important, and some people are just like, well, you shouldn't post these things because they don't matter, but it shows other people. One, it shows them what you're working on. It also shows them that you are where you are in your journey. So if you just finished something, let people know, hey, I just finished this. It goes into areas where when employers are looking at how did you build up your skill set, and like for people like me who didn't come from the statistical world, I didn't come from the mathematics world, I came from the healthcare side of things. So that is what my background is in. So we're gonna get going to the next part of this, which we finished up the analytical tools. Now we're gonna go back and we're gonna do visualization.
Of our analysis, we bring value to our businesses. For these reasons, Comptia includes data visualization as one of the 5 key domains covered on the Dataplus exam. Hi, I'm Mike Chapple, and I'd like to invite you to watch my course on data visualization. It's part of a 6-course series preparing you for the Dataplus exam. I hope that you'll join me as we explore the basics of reporting, dashboards, and visualization techniques. I've designed this series of Dataplus courses with the beginner in mind. While you'll probably find it a little easier to complete this course and the Dataplus certification if you've worked with data before, that's not a requirement. If you're looking to get started in data analytics, this course series
All right, let
will
me get you
provide you
guys
with
because
all
you
the
guys can't see
information
the
you
right
need.
screen now.
If you're a
so-
technology professional with some data experience under your belt, this
All
course
right,
series will
sorry
help you
about
fill
that.
in any gaps in your knowledge and build a solid foundation as you prepare to take the Dataplus exam. We communicate the results of data analysis to our stakeholders using a variety of tools. The 2 most common categories of communication tools are reports and dashboards. A report is a document that contains information from a given point in time. It can be printed on paper or delivered in electronic form, but once a report's created, the information in that report usually doesn't change. As an example, the sales management team might receive a weekly sales report showing the results of the team's sales efforts that week. A dashboard, on the other hand, is an interactive visualization that encourages people to explore data dynamically. Instead of providing a snapshot of the data at a point in time, dashboards often provide real-time access to data and let the user explore that data interactively. Dashboards are normally delivered electronically to allow this type of interaction. As you develop a report or a dashboard, you'll need to base your work on the business requirements at hand. Why are you developing this report? Who is the audience, and what should they be able to do with the data that you're presenting? The type of report or dashboard that you create might vary significantly depending upon the answers to those questions. For example, imagine that you run a hotel. You might need to create a dashboard for the housekeeping manager showing which rooms still need to be cleaned that day. This dashboard needs to be very tactical. It's helping to make real-time decisions about assigning specific housekeepers to specific rooms, and the manager needs to know what rooms are still dirty at any point during the day. The dashboard should provide that specific information. On the other hand, the general manager of the hotel has more strategic needs. That person doesn't get down into the details of what rooms need to be cleaned at any given point in time, but they're more interested in looking at the efficiency of the housekeeping department over the course of a week, a month, or even a year. The reports and dashboards that you design for this type of executive would help them assess that performance at a strategic level, but they wouldn't be useful to a frontline manager trying to decide what rooms need to be cleaned next. Once you clearly understand the audience and their needs, you can turn your attention to identifying the data content that will satisfy the requirements of your audience. You may need to combine data across multiple subject areas. For example, if you're working with corporate executives, you might need to combine data from various divisions within the organization. Sourcing this data can be a challenge, as you might need to pull data from several different systems as you create a single report or dashboard. As a data analyst, your job is to ensure that you have the right access to the appropriate data sources to meet your organization's reporting requirements. As you design reports and dashboards, you'll need to consider ways that the data might be filtered for the end user of a report, or the ways that you'll provide filtering capabilities on an interactive dashboard. Filtering is just sorting through the data sets used in the analysis and removing any data that isn't relevant for your purposes. For example, one of the most common ways to filter data is by date range. You might create a financial reporting dashboard and set it to include data from the current year by default, but then allow the user to alter the date range shown on the dashboard to look at prior years or shorter periods of time. The same dashboard can then be used to look at performance over the past few weeks or the past few years. In most reports, you'll want to filter by other parameters as well. For example, you might want to filter your financial reporting by division of the company to help the leaders of each division evaluate their performance. This type of filtering by data content allows different leaders within the organization to use the same reports and dashboards to analyze their areas of responsibility. It provides different individuals with different views of the report based upon their own unique needs. Once you identify who needs what data and when they need it, you can focus on how people access the report. The two main choices that you have are a pull approach and a push approach. In a pull approach, you publish a report to a web page or other location, and then let people know where they can find the report and the frequency with which it will be updated. In a pull approach, users can access the report whenever they need it. This approach is also often called self-service or on-demand reporting. In a push approach, the report is automatically sent to the appropriate people as it becomes available. A push approach sends the report directly to the inboxes of users at a defined frequency. You might deliver a report daily, weekly, or monthly, depending upon the business requirements. When you use a push approach, you'll need to maintain a distribution list of the individuals who need to receive the report, adding and removing recipients as people change roles in the organization. When you distribute a report, the cover page is the first thing that people will see. That makes it very important, as it's people's first impression of your work. The cover page should set expectations about the observations and insights that the reader will find inside the report. Effective cover pages have a concise title that describes the contents of the report. Ideally, a cover page will also communicate a significant insight from the report itself. As the saying goes, you never get a second chance to make a good first impression. The cover page has to entice a person into turning that page and diving into the report. Here's the cover page from Microsoft's 2020 annual report. It's a nice clean design that communicates the purpose of the report, identifies Microsoft as the author, and then includes an image that conveys the company's priorities. In this photo, you see people using a Microsoft product across generational lines. You get a good sense from this cover page about the nature of the rest of this 92-page report. Your report should also include clear instructions on how to use the report. For example, if the report analyzes 5 years' worth of data, the range of years should stand out on the cover. If the report is intended for specific audiences, mention that as well. If you use complex visualizations, you should explain to the reader how to interpret those visualizations. Here's an example of report instructions from Verizon's Data Breach Investigations report. In this annual report, the company provides insight into cybersecurity incidents that they investigated over the past year. These instructions explain how the reader should use and interpret the contents of the report. After the cover page, there should be an executive summary that provides an overview of the report's contents. When you create an
I
executive
know
summary,
when we get
you
ready
should
to do
begin
the
with the
studies,
end in
we will have
mind.
to go
Summarize
into depth
crucial
about this
observations
as
and
well.
insights. Time is an executive's most precious resource, so the summary needs to convey the big ideas, while the body of the report can detail the analysis that led to those ideas. Here's an example of a well-written executive summary. This comes from a report issued by the Government Accountability Office on the training of medical consultants. Now, the full report is 31 pages long, but this one-page summary provides all of the most important information for executives. It explains what the report studies, what it recommends, the key takeaways from the report, and it has a boxed section clearly describing why the report matters. That is a great executive summary. If you don't read anything in this report other than this one page, you still get the main idea. If you'd like more detail, you can dive into the other 30 pages. The design of a report or dashboard is crucial to its success. People are drawn to visually appealing materials, and if your visualizations are well designed, they'll be more useful to your stakeholders. You'll want to think through many different design elements when you create a report. You'll want to think about color schemes, page layout, font size and style, charts, and corporate standards. A color scheme is a limited selection of colors that you use when creating a report or a dashboard. The colors are designed to work well together and complement each other. If you're printing reports, you may choose to use a monochromatic palette that limits you to working with shades of a single color. If you're trying to print materials on a budget, using a monochromatic palette can help keep your costs low. If you have the luxury of working with more than one color, you can use a complementary palette that starts with 2 contrasting colors like red and green, orange and blue, or yellow and purple. The complementary palette then adds other complementary colors that work well with your scheme. If you're designing a report for visual display or have the budget to print in full color, a complementary palette is much more appealing than a monochromatic palette. Using either one of these palette types helps ensure that your report uses colors that work well together. Next, you'll need to think about the layout of your report or dashboard. This is how you will arrange the different parts of your visualization on the screen or the printed page. It's a good idea to lay out your visualizations logically in a manner that helps the reader understand the story that you're trying to tell and follow along. If you have a long multi-page report, include a table of contents to help readers find the topics that interest them most. Using clear headings for sections and subsections makes it easier to skim through the report. You should also think carefully about your choice of font styles and sizes in the report. When you choose a font style, pick one that's easy for people to read by avoiding ornate fonts. Fonts come in 2 main categories. Serif fonts include finishing details called serifs that make a font easier to read and help the letters flow together. Commonly used serif fonts include Times New Roman, Georgia, and Courier New. Sans serif font styles exclude these details. They're usually a little more difficult to read, especially when you have a lot of text. Common sans serif fonts include Helvetica, Arial, and Geneva. Once you've selected a font style, determine the appropriate font size for your title, table of contents, headings, subheadings, and body text. We measure font sizes in points, with each point representing 1/72 of an inch. Start with your body text when you're determining font sizes. That body text makes up most of what a person reads, so you want to make sure you don't pick a font size that's too small. It's pretty common for body text to range between 12 and 14 points in a report. After you select a font size for your body text, use progressively larger sizes for subheadings, headings, and titles. Selecting an appropriate font size is crucial when you're printing reports because the size is going to become fixed during the printing process. However, font size is less critical when you're distributing reports electronically, as recipients may adjust the overall font size on their computer, tablet, or mobile device. Reports and dashboards often use graphics to present summary information because visually conveying information with charts helps focus your audience's attention. Think through the key chart elements when you're designing charts, including the chart's title, labels, and legends. When you create a chart, make sure that you include a title. The chart title should use a large font size and concise wording to clearly describe what the chart depicts. If necessary, you can use a subtitle to supplement your title with additional information to add clarity. In a chart with an x-axis and a y-axis, a label describes what each axis represents. This chart shows how a vehicle's engine displacement
All right, this is
on
your
the
5-minute warning, you
x-axis
guys.
relates
So
to its
5 minutes,
highway
we're going to
efficiency
go
in miles per
on our
gallon
first
on the
5-minute
y-axis.
break.
If these axes
So
didn't
just
have
make
labels
sure
and the
that
title was
you're
missing,
getting prepped.
a
This
person
is just
wouldn't
a
know
warning.
what information the chart is meant to convey. When a chart uses multiple categories, use a legend to help the reader distinguish between categories. For example, this chart shows Ford and Volkswagen's corporate average highway fuel economy in miles per gallon. The legend indicates that the data in the chart for Ford uses circles, while the data for Volkswagen uses triangles. When you develop any type of visualization, be mindful of any corporate reporting standards that might exist in your organization. For instance, your organization may have a style guide for reporting. A style guide is a set of standards that drives consistency in communication. As a means of enforcing structure and consistency, style guides define the use of a variety of branding elements, including page layout, font selection, corporate color codes, logos, and trademarks. For example, Uber provides employees and contractors with this corporate style guide. It explains how to use Uber's logos, trademarks, and other branding, the colors that should be used in different situations, the fonts preferred by the company, and many other style elements. This type of guide helps employees throughout the organization design materials that will have a consistent look and feel. Here we can see the color guidelines for Uber. Notice that the guide provides each color's role in the palette, and then it also provides color codes that can be used to exactly reproduce each color digitally and in print. Style guides can also explain the use of watermarks. Typically a text or a logo, a watermark is superimposed over a report or web page. These watermarks may identify the company or include use restrictions, such as noting that a report is a draft or for internal use only. In larger organizations, you'll probably have a communications department that's responsible for developing brand standards. When you create visualizations, make sure you work with those communications colleagues to ensure that you're doing your part to project a consistent image for your organization's brand. The people who use your visualizations have to trust the information that they contain. To build this trust, you can incorporate documentation, including version numbers, reference data sources, and reference dates. These elements serve as guideposts to help readers understand where your data came from and how current it is. There are two main dates that you should include in your reports and dashboards. The first is the report run date. This is the date that the report was generated, either by a user or an automated process. The second important date is the data refresh date. This isn't the date that the report was created or modified, but it's the date that the data underlying the report was last updated. This is especially important to include when you're pulling a report from a data warehouse where the data might not be constantly updated. As the layout and design of reports and dashboards change over time, you might want to include a version number that identifies which revision of the template is being used. Users can just look at the version number and tell which of two copies of a report is most current by selecting the one with the highest version number. Anytime you present data in a report or dashboard, you should include the reference data sources that were used to create that data visualization. This helps the reader understand how much confidence they can place in the data, and also tells them where they can go to find the source data if they'd like to perform their own analysis. When you develop a report or a dashboard, it's a good idea to maintain a set of frequently asked questions, or FAQs. A FAQ provides answers to people's most common questions. If the dashboard is available online, the FAQ can contain links to a glossary of unique terms, cross references to other dashboards or reports, and contact information if someone has additional questions. You can use an appendix to include supporting details that are inappropriate for the main body of the report. For example, if you use statistical analysis to derive the central insight for a report, instead of detailing each calculation in the main report body, move them to an appendix. That way, the general reader will not feel overwhelmed by the details, while the informed reader can explore those calculations in detail in the appendix.
All right. We have just under a minute. We will come back and we will answer these questions. So, in that break time, please enjoy your break. Please get up and walk around, do what you need to do, but please don't just sit down for the break. The whole point is for you to get an opportunity to get up and move around. So enjoy your break. All right. So, welcome back. Okay, so let's take a gander at these questions. What approach in reporting allows users to access reports on demand? Um, pull. Okay. The executive summary of a report should appear at the front of the report and include the key findings. True. What type of color palette is most appropriate when printing documents on a tight budget? Monochromatic. Where would you include mathematical details of your analysis to help readers explore the analysis in more depth? In the appendix.
Dashboards are dynamic tools that help people explore data to inform their decision making. Now, because dashboards are dynamic, their design, development, and delivery mechanisms are more complicated than the ones we use for reports. Let's explore some of the considerations that you should keep in mind when developing dashboards. Just like when you create a report, it's crucial to identify who is going to be interacting with every dashboard that you create. For example, C-level executives like a company's chief executive officer and chief financial officer have very senior leadership positions. A dashboard designed for them needs to consolidate critical performance metrics with the ability to get additional detail on an as-needed basis. This helps people with these senior responsibilities to make strategic decisions. When you develop a dashboard for executives, you should identify the key performance indicators, or KPIs, that are crucial for senior leaders. KPIs are metrics that leadership agrees is crucial to achieving the organization's business objectives. Once you know what leaders want to see, you can then locate where the relevant data exists in your organization. A large organization typically has external stakeholders who serve on its board of directors. While the board's needs closely align with the needs of C-level executives, you need to incorporate any of the board's unique requirements in your dashboards so that board members can fulfill their oversight and corporate management duties effectively. Lower levels of management focus on a different set of metrics than senior leaders. While the information needs to differ from that you might present to the C-suite, management dashboards are also critical to the organization's success. To ensure that those dashboards are going to add value, make sure you work with managers to identify the information that they need to lead their portions of the organization effectively. You might also develop dashboards for people external to your organization. For example, your organization might enter into a service level agreement, or SLA, that describes a level of service an external vendor or partner can expect from you. Violating an SLA can result in financial and reputational damages. To help communicate clearly and with transparency, dashboards that are available to the general public provide a single source of information for anyone interested in the status of your services. For example, here's a publicly accessible dashboard for Amazon Web Services, a cloud service provider. Examining this dashboard, we see a list of services and their operational status. In addition to showing the current status, you can opt in to receiving status updates for any service you're interested in. In your work, you might need to develop a dashboard like this for technical experts. The people who use this dashboard could have functional or technical responsibilities. Someone with financial responsibility might only want to know when the outage violates an SLA, but a technical expert using the service wants to know more about any outage that takes place and how it could impact the services that they use. Once you know what requirements
All
your
right.
dashboard
So
needs to
we're in the
meet,
last
you can
five
then begin to
minutes
identify the data
of
sources that will
our
provide that
classes,
information.
and
The
we'll
first thing
finish
you
up
should
this
determine is
course and
whether your
then kind of
dashboard
go
needs to
ahead and
contain
bow out.
live data or whether static data is acceptable. Both of these sources are accurate data, but the difference is in how current that data needs to be.
Actually, you know what? We'll
Static data
probably
is data
just
that
end here.
refreshes at some regular interval.
That way,
For
we're
example, you
not
might draw
going
data
forward.
from a data warehouse that
We can kind of talk about a couple of things very quickly. So the next time that we should meet will be on Saturday, not Sunday. We'll meet on Saturday. We'll do about an hour on Saturday. So I'll set up the information for that after this stream, and then that's about it. All right, so that is about it. You guys enjoy the rest of your day. I'll see you on Saturday morning. Thank you so much, and I'll talk to you guys later.